Hi everybody, welcome back to our 11.6 notes. This is our last part, our part 3, and we have 3 examples left where we're going to be graphing. We're going to look at how are they different from that x squared graph, and how to graph them quickly, and how to identify some of the major features, as well as the domain and range. So for the next one that we have, in example 5, part B, I have g of x equals negative 2 times x plus 1 squared minus 1. So let's talk about what everything is doing, okay? So the negative out front, what that's going to do is it's going to flip our graph. It's going to be an upside down U instead of right side up graph, okay? So we're going to flip to be upside down. What does the 2 do? The 2 is that thing that stretches it, which makes it a skinnier graph, but we have a vertical stretch of 2. So, stretch by 2. And then inside of our parentheses, we have an x plus 1. And that plus 1, right here, what is that going to do? It's going to move our graph left 1. And then we also have this minus 1 over at the end. And so that minus 1, what's going to happen is it's going to move our graph down 1. So that's what everything's doing. Let's put it all together and go from there, okay? So first question is, where's my vertex going to be? Well, my vertex used to be at 0, 0, but I'm going left 1 and down 1. So now my vertex is at negative 1, negative 1. Or you could just look at the equation before doing all of that work and say, okay, it's x plus 1, and so it's the opposite of what's in here to get your h value. So instead of positive 1, our vertex is negative 1 for the x value. And the y value is exactly the same as that number at the end. So we have a minus 1 at the end. So our y value of our vertex is negative 1. Where's the axis of symmetry going to be? So the axis of symmetry, remember, that's a vertical line that goes through our vertex. So it's a vertical line, so it'll be x equals a number. And the number that's going to equal is the x coordinate from our vertex, which is negative 1. Okay. So let's graph it from here, okay? So let's start with our vertex. So our vertex is negative 1, negative 1. And then you can do all of this stuff to a regular graph, which is kind of fun, okay? So normally we would have a point at 1, 1, right? But we're going to flip it, okay? And we're going to stretch it, and we're going to move things around, okay? So we're going to flip it, which would put it here. We're going to stretch it by 2, so instead of being at 1, negative 1, it would be a 1, negative 2. And then we're going to move it. So we're going to move it left 1 and down 1. So we would end up right here at 0, negative 3. If you don't like doing all of that work, it's okay. We can always just make an XY table, okay? So you could just do an XY table if that makes your brain a little bit happier. And once you figure out that the vertex is at negative 1, 1, I would use things around negative 1. So if you have an x value of negative 1, you're probably going to want a couple things to the left of it, maybe negative 2 and negative 3, and a couple of things to the right of it, like 0 and 1. Okay? And so you could start out that way, and then fill out your y's and plot your points, and life is going to be good. But I like introducing you guys to transformations because they actually work for every single graph that you ever could get, which is neat. Okay? So anyway, so we have this point at 0, negative 3. The nice thing is that we have symmetry, right? So if we have a point 1 to the right 1 of our vertex, we also have the same point to the left of our vertex as well. So we can put a mirror image point over here. Let's do another one. How about, we normally have 2, 4. I feel like I should do a different thing. We'll do a star. So we normally have 2, 4. So if I flip it it would end up at 2, negative 4. Then if I stretch it by 2, it'll become 2, negative 8. And then I just need to move it left 1 and down 1. So we're going to be right here, okay, at 1, negative 9. And then we can do a mirror image point on the other side at negative 3, negative 9. And then we have a nice, pretty graph here that is downward shaped, which we knew was going to happen because of that flip. It has a stretch of 2, so it is narrower than our x squared graph. And then it moved around, it moved left 1 and down 1. Okay? Alright, let's you guys try some pieces of the next one, okay? So for part C, all I want you guys to do for a minute is just see, can you figure out where the vertex is going to be? And can you figure out where the axis of symmetry is going to be? Okay? So yet again, pause your video, and I will let you know the answers in 3, 2, 1. Alright, you should have a vertex of 1, negative 2, and an axis of symmetry for the line x equals 1. How'd you do? You do okay? Alright, then I'm going to give you guys a minute. See if you can graph it. You can either graph it using the transformations, which is how I was describing it, or you can graph it using an XY table, okay? So I'm going to give you guys a minute. See if you can graph it, okay? I'll pause the video while you graph, and I'll show you the graph in 3, 2, 1. Alright, so our vertex is at 1, negative 2. Some other pretty points you're going to get would be at negative 1, 0, and at 3, 0. In case you're curious, you'll also have a point right here at 0, negative 1.5, and at 2, negative 1.5. Some other nice pretty points you'll get. The other nice one you'll get is at negative 3, 6. And at 5, 6. And if you would like the in-between point at 4, you'll have a point at 4, 2.5. And at negative 2, 2.5. Okay? So those are kind of the easy points to get. And of course, every other x value tended to work out nicely since you're multiplying by a half. Okay? So that's what we're going to look at here. We forgot to do the domain and range of the last one, but let's make sure that we do the domain and range on this one, okay? So, yet again, pause the video, see if you can figure out the domain and range for this graph, and I'll tell you the answer in 3, 2, 1. Alright, the domain for this one is negative infinity to infinity. The range for this graph would go from negative 2 to infinity. You should have a bracket at negative 2 because it includes that vertex point. Okay? Since we forgot to do it on part B, sorry about that. Got so caught up in all the transformations and everything that was going on that we forgot domain and range. So the domain for part B, if you want to look at that graph one more time, goes from negative infinity to infinity. It goes, it'll keep going to the left, it'll keep going to the right, and doesn't skip anything in the middle. The range for this one, it keeps going down for forever. So we'll start out with negative infinity. And how high up does our graph go? The highest it's going to go is a y value of negative 1. And we'll have a bracket at negative 1 because there is a point there. It's included in our graph. Okay? Alright, we've got one left. And I promise that's the last one of the day, okay? So our last one here, we have h of x equals negative 1/3 x squared plus 3. So yet again, I want to see, can you guys figure out where's the vertex going to be and where's the axis of symmetry going to be? Okay? So again, pause your video and I'll show you the answer. 3, 2, 1. You should get a vertex of 0, 3 and an axis of symmetry of x equals 0. So the 0, 3 is because if you notice that it's just an x squared, right? That would be x minus 0 squared. There's nothing in there, which would be an x value of 0. And then the plus 3 at the end, that's the y value of your vertex, okay? The axis of symmetry is always x equals a number, and the number is always the x-coordinate from your vertex. Okay. Let's see if you guys can graph this one. So again, if you would like to do transformations, you are welcome to do those. We're going to flip. We're going to do a shrink of a third. And then we're also going to move up 3. So that's what you're looking at for transformations. If you want to do an XY chart, you certainly can do that. My advice for you, if you're doing an XY chart, you're about to multiply by a third, which is really like dividing by 3. You might want to pick factors of 3 or multiples of 3 for your x's. Sound like fun? Great. Okay. So give it a try. Pause your video again. See if you can graph it, and we'll go over the answer in 3, 2, 1. Alright, so the graph should have a vertex of 0, 3. Easy points for you would be the point 3, 0 and negative 3, 0. And 6, negative 9, and negative 6, negative 9. Those are the easy points for you, okay? And that's what your graph should look like, is it should be downward, it should be a wider graph, okay? And last but not least, let's see if we can do domain and range for this one, okay? So I'll give you a minute. See if you can figure out domain and range for this graph, okay? So pause your video, write down what you think the domain and range are, and I'll show you the answer. 3, 2, 1. Domain should be negative infinity to infinity, and the range should be negative infinity to 3 with a bracket at 3. Okay, hope this helps. Give it lots of, practice with the graphing. You guys can do this. If you have questions, of course, send them my way. And I hope you guys have a wonderful week.